Okay, so you have gotten past the math part of this class. Now let's jump into some physics. So in this video, you're going to be learning about distance and displacement. And by the end of the video, you will be able to differentiate between distance and displacement. So let's go ahead and start by comparing the two. So both distance and displacement are going to measure how far. So those are kind of things you want to think about is we're measuring how far away we are from where we started in some way. So distance is a scalar. Our units are going to be meters. And when you ask your distance, what you're going to want to think about is how many steps did I take? So if you look at our picture, I started at point A and I ended at point B. And I took this kind of circuitous route from A to B. When I'm figuring out my distance from A to B, I am just going to measure the length of the route that I took. So figuring out how many steps I walked from point A to point B. Displacement, on the other hand, is a vector. Like distance is measured in meters, but our question is really how far away are you from where you started? So again, in our picture, displacement is going to be just the shortest possible route from point A to point B. So I don't really care how I got from A to B. What I care about is how far away am I from my start point. So similarities between these two, they're both measured in meters. And that's really about it. I mean, they're measuring things like how far we are from something, how far we traveled, but in different ways, right? So distance is going to be a scalar, so we're just going to add every single step that we take, and we're not going to worry about direction. Displacement, on the other hand, is a vector. So when we add two displacements together, we're going to worry about how many steps I took and in what direction. So if I take 2 steps forward and 2 steps backwards, then my displacement is going to be 0, whereas the distance I traveled will be 4 steps. So let's go ahead and do an example. And this one is nice and simple. So we've got Tony, who's going to walk 2 steps forward, which I'm going to go ahead and highlight in blue. And then he's going to go ahead and take 1 step back. So we're going to start by figuring out the distance he traveled. And I'm going to go ahead and underline distance I'm going to change the color to yellow here. So I want to figure out how many steps Tony took. So again, remember, how many steps? So distance is a scalar, so we're going to not worry about direction. So we're going to say distance is equal to 2 steps forward plus 1 step back. So 2 plus 1 or 3 steps. His displacement, on the other hand, is a vector. So Tony walked 2 steps forward. So I'm going to say 2 steps to the right is going to be 2 steps forward. And then he walked 1 step backwards. So if I say forwards is positive, backwards is negative, I can draw my resultant vector here. And what I'll say is he walked 1 step forward. So he's 1 step away from where he started. So I know now Tony's distance is 3 steps because he took 3 total steps, but his displacement is only 1 step because he's only 1 step away from his start point. So let's go ahead and talk about takeaways. First of all, we know that distance is a scalar and displacement is a vector. And so what that means is that when we are figuring out distances, we're going to do scalar addition, aka 2 plus 2 equals 4, 6 plus 6 equals 12, and so on and so forth. Displacement, on the other hand, is a vector, and so we're going to have to do all of our vector addition rules. So now you see why we did all that vector review, and hopefully you are comfortable now finding distance versus displacement. So go ahead and give it a try on your own, solve some problems, best of luck, and happy solving.